Right. So, apologies for. How about this? I'll rephrase it. Welcome, Algebros, to my TED Talk today. Today, we're going to talk about inspiration in the world of mathematics. So, come along with me on this journey.
That's exactly what the dude said.
That's kind of what they. All I needed was the water droplet and the big bassy sound there, and then
it was just the slow, spaced out words.
yeah. My favorite TED Talk too, as well, is the one where the guy just talks about how important your like tone and intonation is to try and make a speech like interesting. But he literally is up there saying like, "I am saying nothing important. I am just using different tactics right now to grab your attention," and it's good. Anyway, I'm not going to show it to you because I make fun of him too much for that. Moving on, shape proofs. Let's go. When I see something that looks like this, I kind of want you to start at the end. What I mean by that is, for a shape proof, what matters most is this right here. Show that triangle PQV is both a right triangle and an isosceles triangle. So that matters the most. As soon as I see that, I'm literally just going to go up to the top and make my list. So prove. Okay? So I'm going to go A, I guess, because I'm going to do numbers after. So the first thing that I would have to look for, let's say the right triangle part. So looking at the diagram, where PQ and VQ meet is going to be the 90, right? So I want to prove the following, basically that the slope of PQ, okay, is perpendicular to slope of VQ. That's the first thing I want to prove. Okay? The second thing is going to be, if I look at it as an isosceles, right? I want to basically prove that length of, so, and I'll do this clear with a different color or something. There's different ways to kind of do it, but in terms of the things that you'll see, when they go something like PQ and put a line over it, they're talking about the line segment PQ. As soon as it has a hat, right, they're saying line PQ. That distance is equal to VQ. And I'm choosing those two because I know it can't be the hypotenuse, which is going to be the longest side that is opposite the right triangle, right? So that's basically it in a nutshell. You putting those two things and then check marks next to it is like your way of like validating that you've shown blah, blah, blah. The next thing I would do, so this is my step one, write out like a statement. My step two is going to be just basically label. Okay? And what I mean by that is point P is on the x-axis. Okay? What do I know about something that's on the x-axis? What do we know about it? X-intercept. So I know that y is equal to 0, meaning right here is x and 0. Just doing this is all free marks, right? Because I'm not sure you know that. But as soon as you write x and 0 there, boom. I now know that you know what P is. And you know that the x-intercept is where y is 0. Okay. The next thing is the rule of this line. So PQ is 3/4. So if you want to write it on here, like 3/4 x minus 27, and then this guy here is y is equal to negative 4/3 x plus 248. Doesn't hurt, right? Doesn't make a huge difference, but it also doesn't hurt. And then the last thing they say is, hey, measurement of VQ, and you know it's measurement because that line segment on top of it. It is kind of annoying that we use slope as M, but anyway, that's more of just the way they write things. So they're basically saying from here to there is 120. Okay? So now when I start to look at it, there's going to be a couple of things that stick out to me. Okay? What are the things that I can maybe solve for right off the bat? Well, the easiest thing on this guy here, yeah, let's take a look at proving A first. So for our third step, we're actually going to get into it, right? So let's go find perpendicular, right? What I mean by that is like, let's go prove that guy right there. So I labeled VQ with that rule, and I labeled PQ with that rule. If we're just talking about finding whether or not slopes are perpendicular from one another, really, okay, I really like that. That's exactly it, Cameron. I want to look at one thing. I'm going to highlight it here. Let's just look at what's the slope of that guy. What's the slope of that guy, right? So that's all we're going to do. So let's take a look at slope of VQ first, which is -4/3. Couple of ways to do this, okay? A lot of people actually in the other class were doing this, and I kind of thought it was maybe a little bit easier, or maybe it was this group here, I'm not sure. But can you tell me right off the bat, how do you find what's perpendicular to -4/3 just doing our fraction stuff? What are our fraction rules with this stuff? Flip and switch. So perpendicular to that guy would be now 3/4, but positive 3/4. Because that matches the slope of PQ, right? So they're both equal to 3/4. Then I can put a check mark next to it and say, hey, yeah, like I flipped and switched, it's good, right? So because this guy was -4/3, because I did the negative reciprocal or flipped and switched it, and because that slope is the exact same as the slope of PQ right here, then I can say that it's good. However, as an alternative, right? As an alternative, some of you guys I know like your you like your decimals. So -1.333 repeating. And you've got a slope of 0.75. And that's totally fine. And you can definitely use this and use that formula, right? Slope times a perpendicular slope should give me -1. So if I go -1.3 times 0.75 and I get -0.75, I can say those two things aren't perpendicular. But what did I just do wrong? I times them by each other, but
you rounded.
I rounded.
That's why Miss Cindy always tells you
Tons of
3 decimal points after the.
I hammered the button. 1.3333333 times 0.75. Because this is wrong, right? If you're going to use this formula correctly, -1.333 repeating times 0.75 should give me -1. So whether you want to do it this way, whether you want to do it this way, it's entirely up to you. And that's where this unit can be a little bit tougher, is it's like there's not really one way, there's a couple of ways. Okay? What would you prefer to do anyway? Here, let me just pause this for a sec. So whatever way you choose is fine with me. Whatever way you write it out is fine with me. The next part becomes a little bit more difficult. So let's start to think about what we need here. And there's two things we need here. So I'm going to just go step 4. Let's think about it for a second. We need the distance of PQ. So, and this is more like a thinking aloud as you're sitting there in your next step. You're like, okay, I've proven the perpendicular, that's done. So now I got to prove that segment PQ is equal to segment VQ. And I already know that VQ is 120. So I don't need to find that one. I really just have to find PQ. So for the distance formula, what do you need? When you go to plug in, D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. What do you need for that? I need 2 x and y's. I need 2 points. So I have to find both P and Q, right? I have to find both P and Q. So in order to find P and Q, and let's just go, so Step 4 we'll say is find distance of PQ. And if you put the formula down, right? X2 minus X1 squared plus Y2 minus Y1. Even just you doing this, like you don't have to do this here, but this is just more of a thinking prompt to help you as you work your way through it. If I'm looking for those two things, I'm like, crud, need 2 points, meaning I need P and Q. So that's just more of like step 4 is like maybe like a me thinking about it right now. Okay. So let's go to 5th step and actually let's find P first. And literally, I'm going to pause this and I want you to try finding that guy on your own right now with the information provided. So to give you a little bit of a hint, what I would do is, hold on. Oh no, not that one. Okay. So if I just gave you this line here, told you that that's the rule for that line, and that we know that the point we're looking for is the x-intercept. I have the rule. I know it's the x-intercept, so I know y is. So all I would have to do to find p is plug it in and solve. That's it. As soon as it becomes part of a shape, people get kind of caught up with it. So go ahead and try and solve that guy there. I'll just erase this. But yeah. And this will come when you do Q as well, you're gonna have the same kind of aha moment. So basically here's a scenario. I've already kind of set it up. Hopefully you know how to use the rule to like plug things in and solve it. This like linear functions 101. So if I have y is equal to 0 and I plug it in, and I kind of ran through this quick, we're literally just isolating for x and we get 36. So what's good about that is I didn't just get x as 36. I actually found point P where when x is 36, the y is 0. So I'll be able to use that in the distance formula. So in terms of need 2 points, I can write that here as well. That's going to be my x1, y1. Good to go. Now, let's go back up to the diagram again. I did that part. This is the trickiest part of this question. The other point you need is point Q. Okay. Again, it being a triangle makes it kind of tough, but if I go down here and just kind of sketch it out again, I'll erase it after, but if I go step 6 and say find Q, and all I'm going to do is just show you, right, that these two things, you already know this rule. Y is equal to 3/4 x minus 27. You already know this rule. Y is equal to negative 4 over 3x plus 248. I know those two things. Q is where the two of them meet. Did we have a skill set to figure out where the two lines meet?
Division. Or no, not the, no. Sorry.
You're in the same. You're in the realm.
Yeah, sorry. Wrong.
Right? We have a rule for this guy. We have a rule for this guy. Yep. Do we remember our systems of equations? So we're just going to use comparison. Right? Y is equal to y. So negative 4/3 x plus. How many people would have got that? Yes, no?
I would have gotten it. I just didn't know what you were trying to get at.
So that's the only thing that's the hard reality, right? Is that like whether I draw it like this or like this, you've got to try and go through your Rolodex of what are the skill sets I have within the world of linear functions, right? Which is a broad world, to find out what Q is. So I already have the rule. What's really annoying about Q and what should tip you off is if Q, you have neither X nor Y, you're going to have to do some sort of systems thing. Because the only way for us to find a point where we don't have X or Y is to use the two rules and find the point of intersection. That's it. Yeah?
What's the point of having the 120 units?
The what?
The 120 units. Like, what's the point of them?
What are we, go back up at the top here. What are we trying to prove? We're trying to prove that the slopes are perpendicular. We're also trying to prove that PQ is equal to VQ. So if we didn't have the 120, we would have to solve the distance of that as well. But they gave it to us, so it's making it easier for us. So the toughest part about this guy is getting that distance of PQ. So we're taking our knowledge of linear functions to figure out what the x-intercept is. We're also using our knowledge of linear functions and systems to identify where Q is. But where these questions become challenging is that you're mashing analytical geo skills, linear function skills, system skills, all together in one question. Shape proof skills, right? So I'll have you work your way through that guy there to figure out what your meeting point is. So there's two ways to think about it too, JC. If you're looking at this guy here and we combine our like terms together, are you going to use the fractions or are you going to use the decimals? Because don't know. Okay, so here's what I'll suggest. If you want to combine these guys, right? Because at this stage, what are we doing? We are combining like terms. So as a review in terms of how we got here, finding Q is a systems question. We're going to compare them and find the point of intersection. Because two lines run into each other, we know at some point they share a y that also shares the same x. So we can basically get rid of the y's and then rewrite one rule on one side and one rule on the other, and then solve for x. When I combine these together, if you want to combine fractions, feel free. Some of you have calculators that kind of make this process quite easy. However, let's just say on this guy here, we're going to use decimals instead. Am I assuming that this is the way most of you would, or right? Yes, no, maybe so? Probably? Okay. So there's an importance of being accurate on this, and we kind of talked about it earlier at the beginning of it. If I combine like terms on this guy here, and I go ahead and say, let's bring this guy over here. So x is combined. Integers combined, right? When I subtract the negative 1.33x, I'll be adding 1.333x to both sides, which gives you a funky number. Like if you're not careful, if you go 2.08x is equal to, bring these guys over, 275. If I were to just round to that right there, 2.08, I get something like x is 132.2, right? Not a big deal, but it's going to throw off your numbers from there, and the question's not going to be perfect. And keep in mind, you need this to be perfect in order to prove that 120 is equal to 120. So if you're lazy, it's not going to work out. What happens instead of doing this nonsense? Okay, instead of going 2.08, I actually take the full thing. 2.08333 repeating, right? X. So we'll say X is equal to, and again, I'm going to use my calculator, whether or not you have a button for this or you just mash that 3 a bunch of times. Really. 2.08333 repeating. Mash it. X is going to be exactly 132. So they do this to hope that they catch you, right? This is kind of that's the trick of this question, is to see if you're going to be lazy and round things off and not be perfect. This one matters that it's absolutely perfect. Okay. Questions on that in terms of how you would do it? Do you have a fraction button that you guys have on your calculator, or would you just
I got Apple, but I can't.
figure out how to use it?
I don't know if you found it last class.
No, yeah, yours was weird.
It's a
I just matched
something slot.
Yeah.
Yeah,
Okay. So, yeah, basically it's try and be as accurate as possible, whether you're just like finding some sort of repetitive button on there or mashing the button a bunch so that you get it to work out for you in your favor. It's entirely up to you. But once I get the 132, you may have forgotten, but I still have the rule, right? And now that I have x is 132, well, I can easily find the y because we can just plug in x is 132 and solve for it. Now, before you ask, Alex, could you have plugged it into the negative 4/3 x plus 248? Yep. It's going to give you the same answer. Do I need to do it twice? Nope. Right? Once I get to here, y is equal to 72, I'm good. And then 132 and 72. That's point Q. I can now put that up here, right, with this guy. I'll scroll down later, but 132 and 72, and we can use our distance formula. Okay? And I can tell you if you plug it, this guy here as x1, y1, x2, y2 into this guy here, surprise, surprise, it spits out a distance of 120. Therefore, you can basically check this guy off and then just write at the very bottom somewhere. Therefore, this is a right isosceles triangle. So you just have to write that one last sentence in there. Hopefully the distance formula is pretty good for you now, but I'm just going to leave this guy up here, and that's it. But make sure you check it off and put that last little statement of, I've solved it. So in terms of these guys here, the most important part is deciding how you're going to go ahead and solve it. So if you're thinking about the ways to solve it, there are two options basically. So Alex, JC, yes, getting point R would allow me to look at my list and say, well, what are the things that prove a parallelogram? This side being the same as this one, and this one being the same as that guy there, in terms of distances, okay? So let me just rephrase this here again, just to get started. I just started this one up, and I want you to think about it, because I'll give you the two options, and then you decide how you want to go ahead and solve it and see which one makes more sense for you, okay? So you don't know what point R is, but you have S, you have P, you have Q. You have your list that tells you the things that make a parallelogram, and the list that would allow you to identify things that make a rhombus. So we're trying to prove that it is not a rhombus, but that it is a parallelogram. So if I go to my list of parallelogram, it says opposing sides being the same. As you can see here, I've kind of double dash, single dash, single dash. That just means that those would be the same. Okay? So opposing being the same length, opposing being the same length. Or it says opposing being the same slope, opposing ones being the same slope. You with me so far? So slopes, if they're opposing, good. So I can use either one, either or. You can actually do a mix and match, right? You could, as we said earlier, slope and distance, really whatever. Okay. If I want to prove that it's not a rhombus, the one thing that would be the easiest is to go, well, four sides need to be the same for a rhombus. So if I just prove that two aren't the same, I can already disprove that it's a rhombus. So let me walk you through the easy way to think about this. I'll give you option one right now. So Cameron, option one, right? If you just use comparison and find R, right? We set this equation opposite that equation there, and we find R. We can then do all four distances. Okay? That would be option one. If I do all four distances, I can then prove that it is both a parallelogram and I can disprove the rhombus. in terms of like the strategy and approach, that's the easiest one to recognize. We good with that so far? So just put your pencils down for a second. So I just want you to think about it for a second because I want you to choose one. I don't want you to write down bullets. I want you to choose one of these ones here. So option one is find R and then find all four distances around. Okay. I will not lie to you. This one is like a ton of work because you got to do comparison. You've got two ugly slopes. You got big numbers. You got to go through all that. Isn't distance formula like a nightmare of just like taking the 2 points, making sure that you like put the right values in the right spot? I try and avoid it if I can, and doing the same formula 4 times makes me go a little crazy too. All right. So the second option, option 2, and you can tell me whether or not you like this, whether or not you understand it, whatever, is going to be this. So in terms of looking at this, I already have the slope of this guy here, negative 21 over 20. I already have the slope of this, it's 3 over 4. How do I have that? They gave me the rules and I'm not an idiot. I can see them. So I just label them on there. Okay. I have those two slopes. So if I want to do just all 4 sides parallel, why don't I just use the formula y2 minus y1, x2 minus x1. If you have a choice between the slope formula and the distance formula, what would you rather do? I'm assuming the slope one. It's a heck of a lot easier, right? There's no square root of. You're not squaring things. You're not. Okay. If I do slope of this guy here too, x2 minus x1. Now I'll have a way to actually evaluate whether or not the opposing slopes are the same. The opposing slopes are the same, right? Okay. So first thing would be basically find slopes, PQ and PS, right? So that's part one. What else would I now have to do in order to identify, because this would just help me prove that it's a parallelogram. Cool, that's done. But I also have to prove that it is not a rhombus. What can you do in that vein to make it easier? And is there a way to prove it's not a rhombus without finding R? I have that point and I have that point. Can I do distance of QP? Can I do distance of PS? I don't need to really do anything crazy except for just find distance PQ and PS. So we're just going to do the distance formula of x2 minus x1 and do the distance formula of for that guy there. If those two distances that are running into each other, and these are the ones that would be different, right? Those are the two that would be different. So if this guy's 90 and he's 85, then we can then say, yep, it's not a rhombus. But again, all I want you to think about right now is one way more right than another? And which way do you think you would prefer to solve it? Which way do you think you would have probably done without me kind of guiding you through it in the first place, and then maybe do that one, right? This is really entirely a choice-based exercise now. I'm not going to go through and solve this one because the main meat of these questions is getting this set up, right? What do I have to solve for so I can check off my boxes? So that's as much as I'm going to go over with that one today. I'll stop this guy.